Okay. So, okay, let us see. As we are discussing, if a substance has at least one unpaired electron, then it will be paramagnetic. If it does not have any unpaired electron, then it will be diamagnetic. Okay, so listen carefully. The magnetic moment is of two types. One is your due to the spin of electron around its own axis. That is called spin only magnetic momentum. Okay, spin only angular momentum. Another one is your orbital angular momentum. As the nucleus, as the electron is revolving around the nucleus, it will be revolving in an orbit or orbital. Due to the orbital contribution, sometimes magnetic moment is affected also. Okay, so magnetic momentum is of two types. One is your spin only angular momentum, another is your orbital angular momentum, due to which magnetic property is affected. Okay, but in your case, maximum questions come from this spin only angular momentum. In higher studies, you will get to know more about orbital angular momentum. We will just see little bit of this one here. Okay, so what happens? See, magnetic moment. How to calculate magnetic moment? We are getting the formula for spin only magnetic moment. The symbol for magnetic moment is mu. Okay, symbol for magnetic moment is mu. So mu is equal to n into n plus 2 root over dm. Its unit is dm, Bohr magnetum Newton. Here you can see spin only magnetic moment in dm. dm stands for Bohr magnetum. Okay, so what happens? Now, suppose I'm giving one example. If N, a substance has two number of unpaired electrons, and what will be its spin only magnetic moment? That is mu s is equals to n into n plus 2 root over. Okay, so put the value of n here, 2 into 2 plus 2 root over is equal to 6. It will be coming as 8 root over of 8. So you will get a number like this. Okay, listen carefully. I am going to give you a shortcut. Okay, what is that shortcut? First, you must know whether you are writing the magnetic moment correctly or not. Sometimes what happens, students used to put the formula n into n plus 1 root over. If you are putting like this, then how do you know it is correct or incorrect? I'll put 2 plus 1 root over, so it will come as 6 root over of 6. Check whether this number is correct or not. How to check? Now go for its next number. It is 6, its next number is 7, which is not an exact square. Okay, but here if you are doing it correctly, then you will have a number whose next digit, 8, the next digit of 8 is 9. 9 will be a perfect square, means it will be square of 3. Okay, remember, see, if I am putting n is equal to 4, then I will get 4 into 4 plus 2 root over. So it will come as 4 into 6, 25, 24 root over. Its next number is 25, that is equals to 5 square. But if I am putting in a wrong way, 4 into 4 plus 1, then I will get root over 20. Next digit is 21, which is not a exact square, which is not an exact square. Okay, so you can check whether you are putting it correctly or incorrectly. This is the correct one, but these are the incorrect ones. Okay, so if you know the next digit is 25 and 25 root over of which is 5, then you can write the answer directly. Root over of 25 is 5. Then root over of 25, 4 will be near about 4.9, just below your 5. Okay, write the unit being. Here you can write this will be 2.9 dm, because root over of 9 will be how much? 3. The number will be just below 3. Minus 0.1, put the answer. Again, I am telling you another shortcut. Okay, if you know the n value, if you have 5 unpaired electron, directly put 0.9. Directly put 0.9. If you have n is equal to 5, then your magnetic moment will be 5.9. If you have mu is equal to 3, then n is equal to 3, then mu will be 3.9 dm. 3.9 dm. Okay, clear? Remember one thing. If n is equal to 1, then only mu will be 1 into 1 plus 2 root over, that is coming as root 3. You can write 1.9 dm, but it will be not exact, because we all know root over 3 value is 1.732 dm. So this much you need to remember. If you have n is equal to 1, then magnetic moment will be 1.732. Otherwise, just put 0.9. Okay, is it clear? Moving ahead, see some examples of magnetic moment. If you have an ion Mn2 plus, see, we know the configuration of Mn. Mn25 is 3d5 4s2. Mn2 plus means we have to remove 2 electrons. So you will have 3d5 configuration. You know d orbitals, there are 5 d orbitals. Okay, so put 5 electrons according to Hall's rule. 1, 2, 3, 4, 5. Count the number of unpaired electrons. Count the number of unpaired electrons. 1, 2, 3, 4, 5. So n is equal to 5. Put the formula n into n plus 2 root over bm. You will get 5 into 7 root over of 35, which is nothing but your 5.9 bm. See. Okay. Similarly, you can calculate for, suppose I'll say cobalt 2 plus. Cobalt 2 plus. Then how can you calculate? This will give you cobalt. You know, cobalt has configuration 27, 3d7,4s2. Okay, if I remove 2 electrons, it will give you 3d7. Okay. So, number of unpaired electrons will be, see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So, number of unpaired electrons is equal to 3. The magnetic moment will be 3.9 billion. Okay. Just remember one thing. I am writing something important. If you have D0 configuration, okay, D0 configuration and D10 configuration, okay, so you will have in this case 0 unpaired electron because either there is no electron or all are paired. If I am taking 10 electrons, then all electrons will be paired. So, D0, D10 configuration will give you n is equal to 0, implies mu value will be 0. So, you can say these substances are always diamagnetic. Always diamagnetic. That means if I am taking Zn2 plus, Zn2 plus. You know Zn has atomic number 30 means 3d10 4s2. 3d10 4s2. Zn2 plus will have a 3d10 configuration. So n value will be 0. Mu is equal to 0. So it will be diamagnetic. Clear? See, these are the magnetic moment increases with number of unpaired electrons. If number of unpaired electrons increases, mu value also increases. You know this one. N is equal to 2, then mu is equal to 2.9 or 2.89. See, in the examination it will be given as 2.89. Don't say that sir told 2.9, we will not write 2.89. Okay. So, if n is equal to 4, then mu is equal to 4.9. So, there is an increase in the mu value with increase in number of unpaired electrons. We can see from here also. Okay. So, in this table, you can clearly see if you have D0 configuration, number of unpaired electron is 0. So, magnetic moment is 0. This is the theoretically calculated magnetic moment. It is the experimental value. Okay, observe and measure experimental. See how much coincidence is there that all values are approximately nearer. If you have one unpaired electron, like in titanium 3 plus, you have one electron, so its magnetic moment should be root over of 3. That is equal to 1.732. See, the value is coming nearly 1.75 experimentally. Okay, you can verify this one from any standard book, or here you can take a screenshot also. You can see this Zn. Zn has 0 unpaired electron, so magnetic moment is 0. Okay. In some cases, I am saying you, in some cases, like this, see, Fe2 plus, you have one Fe2 plus, which has 4 unpaired electrons. So the magnetic moment should be 4.9. Okay, but actually the magnetic moment came in between 5.3 to 5.5. See, in the examination, if you are given n value, then directly calculate μs. There will be no problem. If it is asking, the value should be 4.90, but actually it is giving 5.3. What is the reason? What is the reason? Remember, initially I told the magnetic moment is due to two contribution. One is the spin only contribution, another is your orbital contribution. Okay, orbital contribution. If the values are not in accordance, means they are not nearly equal. See, this is nearly equal, but this is not nearly equal. Okay, in this case, remember only spin, only magnetic momentum is working. But in this case, both spin and orbital angular momentum is working. Where the values are not matching, then you will know both spin and orbital contribution will be there. Spin and orbital contribution will be there. Am I clear? See here, it is 2.84, it is 2.9. Then both are matching. Here only will be spin contribution. Here only will be spin contribution because values are matching. But in these cases, where the values are differing greatly due to both contribution. Okay. And try one or two questions, then we will go to color formation. See, which of the following ion is diamagnetic? Just I told you, if you have Zn2 plus, it will have D10 configuration. It will have 3D10 configuration. So it will be having N is equal to 0, mu is equal to 0. It will be diamagnetic. Chromium 3 is your 3D3. You can see from that table also. From table you can see n is equal to 3, mu is equal to 3.9. Okay, Fe3 plus means 3D5. So it will have n is equal to 5, mu is equal to 5.9. Mn2 plus is having 3D5, so n is equal to 5, mu will be 5.9. Okay, so diamagnetic will be this one. Okay, see absence of unpaired electron. So 3D n is equal to 0, G2 plus will be the correct answer. Okay. Similarly, magnetic moment of diamagnetic substances in Bohr magnetar. Diamagnetic means mu value will be 0. For diamagnetic, mu s is equal to 0. So, 0. The magnetic moment of Fe2 plus. I have already calculated this one. Okay. You can say Fe has 26 electrons. So it will be 3d6 4s2. So what will happen? We will need to get Fe2 plus ion. You have to remove 2 electrons. Remaining are 3d6. Put a box with 5 gaps or boxes. So put 6 electrons according to Hund's rule. So you will get 1 paired electron, 4 unpaired electrons. So n will be 4. Will be 4.9 bn. Check which is near this one. Okay. The ions having maximum magnetic moment is maximum. How to know which one has maximum? It is cobalt 27. 27 means 3d7, 4s2. So remove 3 electrons, it will give you cobalt. Which one? Previous one? Okay, see. What is the magnetic moment of Fe2 plus? Okay. You know Fe has atomic number 27. Outer electrons are 3d6, 4s2. But it is given Fe2 plus ion. So we need to remove 2 electrons from for 2 positive charges. Okay. Where from we have to remove electrons? This is the outermost orbital. So we will remove electron first from 4s. We have to remove 2 electrons. So remaining electrons will be 3d6. Okay. You know this is d orbital. D subshell. D subshell has 5 d orbitals. D subshell has 5 d orbitals. Okay. So put 5 boxes. Okay. Then put electrons according to Horn's rule. What does that mean? Now give one electron to each, then pairing others. ପ୍ରଥମେ ଗୋଟେ ଗୋଟେ ଇଲେକ୍ଟ୍ରନ ରଖିବ, ତାପରେ pairing କରିବ। 6ଟା ଇଲେକ୍ଟ୍ରନ ଅଛି, 1 2 3 4 5, then 6 will come here. Okay, ଏତିକି ହେଇଗଲା 3d6 ର ପାଠ। Okay, number of unpaired electrons, n value. How to know the n value? N value will be, see here, this pair is, this is paired electron. 2 electrons are there in one orbital. 2 electron means it is paired. If it has 1 electron, then these are unpaired electrons. So there are 4 unpaired electrons. This is 4. Okay. So n is equal to 4 means mu, you have to put the formula n into n plus 2 root over. I have told you the shortcut directly. Whatever be the n value, just put 0.9. That will be your answer. Simple. Okay. I think it is clear now. Okay. The next question was cobalt 3 plus Cr3 plus. So here 3 plus means you have to remove 3 electrons. So cobalt 3 plus will have 3d6 configuration. 3d6 means number of electrons. Number of unpaired electrons will be 1 2 3 4 5 6. So n is equal to 4. Mu is equal to 4.9 Bn. Okay. So here you have chromium. Chromium has 24 atomic number. 24 means 3d5 4s1. 3d5 4s1. So you will get chromium 3 plus as 3d3. So it will have 3 unpaired electrons. So n is equal to 3. Mu will be 3.9 Bn. Nickel has 28 electrons. That is 3d8 4s2. So you need to remove 2 electrons. That will give you 3d8 configuration. 3d8, 8 electrons will be accommodated in 5 orbitals like this. 1 2 3 4 5 6 7 8. So So number of unpaired is coming, unpaired electron is coming as 2. Mu will be 2.89 or 2.9 dm. Okay. In copper plus, copper has 29 electrons. That is 3t10, 4s1. 1 electron will be removed for copper plus. So you will get 3t10 configuration. 3t10 means all 5 orbitals of d subshell will be occupied with 2 electrons. Means number of unpaired electron is equal to 0, mu is equal to 0. So height value should be copper 3 plus. Okay, like this we have to check. Okay, clear? Let us go to color formation. You can see. अरे पर्यंत जति पढिले क्लियर अछि okay. Now let us go to the part color. This is very important for you for your council also. Okay. Remember, see, you can see here it is written Ti3 plus, it is purple color. It is shown in the picture also. This is your purple solution. Chromium 3 plus is green. Okay. Manganese is your light pink. Okay. Light pink means just pink, as you have noticed in your titration. Okay, light pink color you can see there. Okay, Fe3 plus. Fe3 plus is giving you a deep yellow solution here. Cobalt 2 plus is deep pink. Okay, nickel 2 plus is greenish color. Copper 2 plus is blue color. Why? Question is why? These are all transition metals. It is saying transition metal ions. Transition metal ions shows coloration. Shows coloration. Why? Why transition metals show coloration? You have to know the origin. Okay. See. The reason is this one. When an electron from lower energy, I'll explain this one. What happens actually? Let us understand. This is due to the color is due to the color is due to D transition. This one D transition. Without this one, you will get no mark. Okay. So remember what is it? D transition. Okay. Initially, you have 5d orbitals. In coordination chemistry, we will also see this one. But here you know you have 5d orbitals. Those are dxy, dyz, dxz, dx square minus y square, dj square. These are the 5d orbitals. Okay. When in compounds or ions, how they behave? Now they split into two parts. They split into two parts. What are those parts? Now remember how they split. The lower energy, this is your energy axis. Okay. We'll get details of this picture in coordination chemistry also. But just remember now, just remember nothing. Okay. Just remember, in the lower side, there will be three orbitals. There will be three orbitals. So which are the three orbitals? Now planar d orbitals. This is dxy, dyz, dxz. Okay. On the higher side, you have two orbitals, dx square minus y square, dz square. So this is one set of d orbitals having three orbitals. Again, I am saying there are five d orbitals. There are five d orbitals. These are divided into two groups. Because these are planes, x, y, y, z, x, z, these are planar d orbitals. These planar d orbitals are forming one set of orbitals. These are three. So it is called T2G. Why T2G? It is called, we will discuss in formation. But remember, these three d orbitals are called T2G. Clear? And here, T stands for triple. Triply degenerate or triple. Tinidioxide, so it is called T2G. Okay. कौन क्लियर नहीं सुनो क्लियर नहीं सुनो ମୁଁ ତମକୁ କହୁଛି ଆମେ ଆଟମିକ ଷ୍ଟ୍ରକ୍ଚର ଲାଷ୍ଟ ଇୟର ଆଟମିକ ଷ୍ଟ୍ରକ୍ଚରରେ ତମେ ପଢିଛ ଡି ସବସେଲରେ फाइव ऑर्बिटल्स है कितना ऑर्बिटल है फाइव ऑर्बिटल्स तुमने बट हाउ पचारिच हाउ इज फुली वन क्लास ऑफ 1.5 आवर्स ओके आमे आउ दुईटा क्लास पर कोऑर्डिनेशन को एंटर करूचे सेठी पूरा डिटेल्स रे याकु कहबी हाउ व्हेन केतबळे माने तीनटा तळे रहिबे केतबळे ऊपर रहिबे एवरीथिंग आई विल डिस्कस ओके बट फॉर दिस चैप्टर तुमको हाउ दरकार नहीं ठीक है तुमको केवल एबे कौन जानिबार अछि जे एमाने पांचटा ऑर्बिटल रु तीनटा dxy dyz dxz होचंती ये तमरा प्लानर ऑर्बिटल आ ई दीटा होचंती एक्सियल these two are axial orbitals axial d orbitals एमाने ऊपर रहिले दीटा इवन एटा 2 আছে 2 इज ए इवन नंबर बोली याकू कहा जाए इजी कौन कहा जाए इजी तुमको वर्तमान पाई सस्पेंस थ्रिलर मूवी वाला जाने रखे था तुम पाखरे दीटा जिंस अछि ओटा हला T2G आ ओटा हला इजी याकू हमें ओपन करिबा बा रीजन जानि दिबा कोऑर्डिनेशन जाता है ओके ठीक है डिटेल्स रे अछि तमरा सेती बेला कहबी ठीक है सो वर्तमान टाइम क्लियर माइंड सेट करके चलो 5 p orbitals are there those are dxy dyz dxz these are planar d orbitals these are called as T2G set and it is staying below and these two dx square minus y square dz square are axial d orbitals they are staying at the above position okay now we will come to what is the transition what happens now suppose I have one electron here means I have a d1 configuration then I will put the electron here because my 5d orbitals are now not together they are splitted into two groups one is T2G another is EG and we know electron first goes to the lower energy level lower is your T2G here three T2G orbitals are there dxy dyz dxz we can put the electron anywhere in these three okay anywhere I'll put here okay the D1 electron will be here in P2G. This is called your ground state. This is called your ground state. Okay, ground state is stable. But what happens when you are putting light radiation? You are giving light radiation. This is your light radiation incident. Light पड़ेगा का energy देला, heat कर देला. ठीक है? What happens when this electron is excited to EG? Means it jumps from P to G to EG. It jumps from P to G to EG. That is one set of d orbitals. One set of d orbitals to another set of d orbitals. Clear? One set of d orbitals to another set of d orbitals. Okay, this jump from T to G to EG is called your DT transition. Is called your DT transition. Clear? Due to DT transition, you are getting one excited state. Means your T to G is empty. EG is having one electron. This is the scenario. This is called excited state because electron jumps from ground state to excited state. Okay, but we know ground excited state is unstable. सबवेले excited state का energy gain करिछि unstable type. Okay, what happens here? The region for color comes. Without DT transition, no color will be observed because देखो आउथरे कहूचे हमर थिला कोठी P2J इलेक्ट्रॉन थिला से एनर्जी पाई की कोठी की जंप करछि EG जेहेतु P2G रू EG को जंप करछि. This is called your DT transition. Okay, DT transition जो excited state पे पहुंचला. Excited state is unstable. जे unstable से सबल ट्राई करिवो एनर्जी लॉस करिवो. एठु एनर्जी h nu जहा पाइथिला ताकि लॉस करिया के से ट्राई कला. एग्जैक्टली सेते लॉस न करि पारे हला करिवो तो फेज करि पारे किंबा एमिति भाबे करे से एमिति भाबे करिवो सो दैट से ए तळ को जंप बैक करि पारिवो. एठी से कोन करूछु जंप बैक करिला. ओके, when the electron jumps back from Q to EG to P2G, it emits energy. This is your emitted energy. Emitted energy. This is your incident energy. It is polyphila. Incident energy. This is your emitted energy. The emitted energy falls in our visible region. Falls in visible region and gives us color. ହେଲା କେତେବେଳେ କଲର ଦେଖଉଛି ଠିକ ରେ ଶୁଣ. again କହୁଛି ଇଲେକ୍ଟ୍ରନ ଥିଲା d orbital ରେ. d orbital ଥିଲେ ପାଞ୍ଚଟା ଦି ପ୍ରକାରର ପ୍ଲାନର ଆଉ ଆକ୍ସିଆଲ. ଓକେ, ଯେତେବେଳେ ଡିଭାଇଡ ହେଇଗଲେ ତଳେ ରହିଲେ ପ୍ଲାନର d orbitals ତାଙ୍କୁ କୁହାଗଲା P2G. ऊपर रहिले axial d orbitals ताकू कहागला EG. इलेक्ट्रॉन ग्राउंड स्टेट रे रहे P2G रे. P2G रे जेतले इंसिडेंट एनर्जी दोउच it jumps from P2G to EG. This is called your DT transition. Due to DT transition, excited state is formed. Excited state is unstable. Electron try to lose energy. The loss of energy is called emitted energy. electron jumps back from Eg to P2G. Okay, due to energy release or emitted, the energy release is falling in a visible region. In a visible region is comfortable, means detectable by our eye. ଆମ ଆଇ ଭିଜିବଲ ରିଜିଅନରେ ଦେଖିପାରିବ। ସେଥିପାଇଁ ଆମକୁ କମ୍ପାଉଣ୍ଡ ଗୁଡ଼ିକ କଣ ଦେଖାଯାଆନ୍ତି? କଲର। କଣ ଦେଖାଯାଆନ୍ତି? କଲର। ହବ? ଆଉ ତମେ କୋଉ କଲର ଦେଖିବ? ନା କମ୍ପ୍ଲିମେଣ୍ଟାରୀ କଲର ଦେଖିବ। କୋଉ କଲର ଦେଖିବ? କମ୍ପ୍ଲିମେଣ୍ଟାରୀ କଲର। କେମିତି କମ୍ପ୍ଲିମେଣ୍ଟାରୀ କଲର ଦେଖନ୍ତି? ତମକୁ ଏଇଟା ଅଲରେଡି ବି ଜଣାଥିବ। ଫାଷ୍ଟ ଇୟରରୁ ଆକାଡେମିକ ସେକ୍ଟରରୁ ବି ଜାଣିଥିବ। ଏଇଥିରେ ବି ଷ୍ଟାର୍ଟିଂରୁ କେବେ ଶୁଣିଥିବ। କମ୍ପ୍ଲିମେଣ୍ଟାରୀ କଲର ଆମର 7ଟା କଲର ଅଛି। B, I, B, G, Y, O, R। ଓକେ, ତମେ ଏଇ I, B, ଇଣ୍ଡିଗୋ ଆଣ୍ଡ ବ୍ଲୁ, ଘନନୀଳ ନୀଳ ଦୁଇଟା ଯାକକୁ ବ୍ଲୁ ନେଇଯାଅ। ଠିକ ଅଛି, ବ୍ଲୁ ନେଇଯାଅ। ତାହେଲେ ଆମ ପାଇଁ ସିରିଜଟା କଣ ହେଇଗଲା? V, B, G, Y, O, R। ଓକେ, ଭିପିଓ। ଠିକ ଅଛି, now V, I am putting here V. For V, the complementary color will be give two gaps. Means leave B and G. Yellow will be your complementary color. Visible complementary color ki asiba? Yellow. Okay. Blue ର complementary color ଦୁଇଟା ଛାଡ଼ିଦେବ ଯଦି କି ଆସିବ? Orange. ତାହେଲେ ଏଠି ଯଦି blue ଲେଖିବି ତାର complementary color କଣ ଆସିବ? Orange. ओके, ग्रीन कि आसीबो? रेड। ताले एठी जदि ग्रीन लिखिदेबी ता कॉम्प्लीमेंटरी कलर कौन आसीबो? रेड। एमिति गोटे साइकिल करदबा ताकि कहंती कॉम्प्लीमेंटरी कलर साइकिल। दिस इज कॉल्ड कॉम्प्लीमेंटरी कलर साइकिल। एथिरे चिन्ह दिबो। ठीक अछि, कौन कहले देखाओ। वायलेट रो के हला? येलो। दुईटा घर छाड़देव एमती लिखिदेकी दुईटा घर छाड़देव। वायलेट पचारछि कॉम्प्लीमेंटरी कलर दुईटा छाड़देले के आसी? येलो। ब्लू पचारले दुईटा घर छाड़देव ऑरेंज। ग्रीन पचारले रेड। अच्छा, जब रेड पचारिबो एमती साइकिल बुलेदेव दुईटा छाड़देव के हेतिबो? ग्रीन। हबा सेतिबे एमती साइकिल लेता देछि। रेड रो के देखो? ग्रीन। ग्रीन रो के? रेड। हबा क्लियर? Okay, I hope you are listening. Next, say when an electron from a lower energy d orbital, T2G is excited to higher energy level Eg. Due to this excitation, the compound shows coloration. तो से एमिति वेरे ताकु भी लिखि देछि। गोटे लाइन रो रीजन रहिला ड्यू टू dt ट्रांजिशन। ओके, ड्यू टू dt ट्रांजिशन मेन इंपोर्टेंट जिंस हला एथिरे मन रखिथिबो के कलर देखांती के कलर देखांती नाही। बहुत इंपोर्टेंट, मोस्ट इंपोर्टेंटली listen carefully now. क्वेश्चन करिया टाइम बहुत हेल्पफुल। ठीक अछि, all D0 and D10 will be colorless. All D0, D10 configuration will be colorless. See, zinc. Here it is zinc sulfate. So you have Zn2 plus. It has 3D10 configuration. So it will be colorless. Again, listen. I have given TiCl4. TiCl4 means Ti has 4 plus oxidation steps. So it will give you Ti Ti has atomic number 22. So this is P2 and 3D2, 4s2. So if you remove 4 electrons, you will have 3D0 configuration. So this is your colorless. This is your colorless compound. Okay. Again, most important part I am going to say now. Listen carefully. There are 3-4 compounds. You can check the color. Now, if I will say this is Fe3 plus. Fe3 plus has a 3D6 configuration. So it will be color. It will be color. You know, just previously I have shown you. This is the color for Fe3 plus. This is yes or no? Okay. So you know now which one will show you color, but importantly, some of the exceptions are there. Those exceptions are some oxides. Okay, I am writing first one. This is anions. In case of anions, these are called oxoanions. Oxoanions. Which are those oxoanions? Remember potassium permanganate, you know, this is the permanganate ion, MnO4 minus. If you find out the oxidation state, Mn will have a plus oxidation, +7 oxidation state. This +7 means manganese has 25 electrons. In outer orbits, it has 3d5,4s2 electrons. If you remove 7 electrons, it will give you 3d0 configuration. So it must be colorless. It must be colorless. Yes or no? But actually it is color. It is purple in color. This is purple in color. Okay, this color is due to, remember, this color here. Another example I am giving you. You know Cr2O7 minus 2. This is your dichromate ion. This is your dichromate ion. Okay, if you find out the oxidation state, it will give you chromium 6 plus. Again, chromium 6 plus, if you find out, it will have 3D0 configuration. So it must be colorless, but actually it is orange in color. This is orange in color. Okay. Just now we have discussed D0 must be colorless, but we are now saying these are color. Okay, remember the region is beyond your syllabus, but you must know the answer in a single word because it is repeatedly coming in NEET, JEE, anything. Okay, the region, remember, is your charge transfer spectra. Charge transfer spectra. Now I know you must be thinking what is charge transfer spectra. Now you just do not need to know now because it is a high level study and this is beyond your syllabus now. But we will discuss little bit in coordination about this. Okay, but for now, just remember this word. If you are getting any 3D0 compound, but it is showing color. Like again, I am saying this is dichromate, this is chromate, CrO4 minus 2. This is your chromate ion. Okay, this is your chromate ion. It is again yellow in color. If you find out the oxidation state of chromium, it will come as Cr6 plus. Again, it is 3D0, but it is yellow in color. So origin will be nothing but your charge transfer spectra. Here is also charge transfer spectra. This orange color is due to charge transfer spectra. Okay, these are the anions. These are the anions. But in the question paper, it is asking which oxide is showing D0 configuration but have the oxidation state but showing coloration. Oxide, neutral compound. In neutral compound, you remember this one. Manganese oxide, Mn2O7 is one of the oxides of manganese, in which manganese has +7 oxidation state. So in this compound, this is neutral compound. Again, it is having D0 configuration and its color is purple. This is due to nothing but your charge transfer spectra. Okay. Here in color you have two things. In whole color formation, you have two things. If your ion is having any configuration between D1 to D9, then it will show DT transition. It will show DT transition and it will be colored. Okay. If D0 and D10 is given, then it must be colorless. If it is not showing DT transition. Okay. Last one is, if your compound is having D0 or anion is having D0 configuration, still it is colored, then the region will be your charge transfer spectra. Okay, am I clear up to this? Am I clear up to this? Now, the next part is your complex formation ability. Okay. We know transition metals are very good at complex formation. Okay. Complex formation means, see, these are the complex compounds. You know ionic compounds. Ionic compounds, NaCl, these are ionic compounds. But when Fe3 plus is getting 6Cl minus, it will form a complex like this. This is giving you FeCN6 3 minus. These are the special properties of transition metals. Other metals easily do not show coordination complexes. These are called coordination complexes. Because between Fe and Cn, there will be coordinate bonds. 6 coordinate bonds will be like this. What is the region? In your examination, it will be asked what is the reason why transition metals or transition metal ions form coordination complex more easily. Okay, the reason is this one. This is the reason for complex formation. Okay. See, you can see 3 points are there. One is your comparatively smaller size. Okay, you know, for coordination means the special type of covalent bond. If my metal size is smaller, then it can directly overlap with orbitals of ligand or incoming. Suppose this is Cn minus. You just know this is anionic species. These are called as ligands. We'll learn about this one in coordination chemistry, but for now, forget about ligand. Just remember this is a species which has the orbital. It has to overlap with metal. If your metal size is smaller, then it will overlap confidently, easily. Okay. So then S block elements, S block to D block size decreases. So their size is smaller. Due to smaller size, overlapping becomes easy. So it is one of the factors for complex formation. Second one is high charge density. We know D block transition metals are electropositive. Electropositive. They have smaller size. In smaller size, a manganese has a plus set oxidation score. So charge is very high. In smaller size, charge is high means charge density is more. Higher the charge density, greater is the possibility of overlapping. Okay, so this is the second reason why transition metals shows complex formation. Most importantly, this is the most important point that if I am giving you sodium plus, it has the outer vacant orbital that is only 3s1. Only one orbital is vacant. But in case of, like I will say, chromium 3 plus is a transition metal. In this case, you have d orbitals, 5d orbitals, in which 3 electrons are accommodated. Still, you have 2 vacant d orbitals. Again, 4s has 1 electron previously. In chromium, if you remember 24, it will have 3d5 to 4s1. This has 1 electron in 4s. Now 4s is also vacant. Okay? 4s is also vacant. What happens? After 4s, there is 4p. 4p is also vacant. Okay, 3 orbitals. So these are they have many vacant d orbitals. Vacant d orbitals can give hybridization easily. Hybridization easily. If orbitals are vacant, they can give hybridization easily. Hybridization में कौन होइजिबो तो जो न्यूक्लियोफाइल बा लिगेंड्स आसीथिबे तम पाखको सेमाने यांकु इलेक्ट्रॉन देई परिबे ए vacant घर this is the vacant orbital it can accommodate 2 electrons easily okay so प्रत्येक घर दिदिटा इलेक्ट्रॉन रहि परिबो जेहेतु एमन एक्सेप्ट कर परिबंती they form complex this is coordination bond they will accept 2 electrons अच्छा availability of d orbitals for bond formation their other term होची they have vacant d orbitals they have vacant d orbitals okay vacant d orbitals they will behave as Lewis acid. Lewis acid they can accept electron pair. I am not saying electrons. I am saying electron pairs. They can accept electron pairs. Accept electron pair. जब easily electron pair accept कर करिबे ताहले more than one pair से accept कर करन देखो गोटे दीटा तीनटा एवला बहुत सारा efficiency रे 6टा पेयर एक्सेप्ट करि पारुछि ସେଥିପାଇଁ ସେ କଣ ହେଇଯାଉଛି କମ୍ପ୍ଲେକ୍ସ ଫର୍ମେସନ ଦଉଛି ବର୍ତ୍ତମାନ ପାଇଁ କୋଅର୍ଡିନେସନ କମ୍ପ୍ଲେକ୍ସ ରେ ପଶିବା ପୂର୍ବରୁ ଏତିକି ତମ ପାଇଁ ସଫିସିଏଣ୍ଟ ଯେ ତିନିଟା ପଏଣ୍ଟ ସଫିସିଏଣ୍ଟ why they give complex and they are due to their smaller size due to their high ionic charge density this is their higher charge density okay ମୁଁ ए अदर टर्म गुडा तो काहे कहूची एमसीक्यू रे ए टर्म गुडा तो पढिथिबो एटा पढताय पारे एटा पढताय पारे एठी सेमती अवेलेबिलिटी ऑफ डी ऑर्बिटल्स फॉर बॉन्ड फॉर्मेशन लिखि दै एक्चुअली एटा को जदि भाग कर लिखो दुटा पॉइंट हे परिबो गोटे होची दे हैव वैकेंट डी ऑर्बिटल्स लास्ट पॉइंट लिख परिबो दे गिव they give a required number of hybrid orbitals, required number of hybrid orbitals for complex formation, orbitals for complex formation. Okay, these are the important 4 points. Which are the points लिखिदेले sufficient. Okay, तमरा एथिरे डी ब्लॉक एलिमेंट रे केवल रीजनिंग ता थिला जे समान काहंती कॉम्प्लेक्स फॉर्मेशन करंती, ठीक है, बिकॉज़ ए चारिटा पॉइंट जो कोऑर्डिनेशन बॉन्ड फॉर्मेशन इजी होती है, ठीक है। सो देखा अवेलेबिलिटी डी ऑर्बिटल चित्र रे देखे देछि पांचटा डी ऑर्बिटल रहिला। सो समान कोन हो जायतंती add up एटा कहला तांकर वैकेंट डी ऑर्बिटल अछि मल्टीपल ऑक्सीडेशन स्टेट हे करूछि लाइक तमरा एटा जानिछ Fe कोन हे करूछि 2 प्लस हे करूछि Fe3 प्लस 3 हे करूछि कोबाल्ट 2 प्लस 3 हे करूछि 3 प्लस 3 हे करूछि वेरिएबल ऑक्सीडेशन स्टेट जो तांकर पाखरे नंबर ऑफ वैकेंट डी ऑर्बिटल्स पड़ जायछि दे फॉर्म कॉम्प्लेक्स। This is now we are getting another property. This is one of the important property of D block element, that is your catalytic property. Okay, this is your catalytic property. Transition metals are efficient catalyst. वर्तमान दुनिया रे जिते catalysis देखिबो maximum cases रे which are involved in transition metals. Okay, why? It is a question. Why they show efficient catalytic properties? Now, it is one of the reasons. They can add up multiple oxidation states. Okay, they can add up multiple oxidation states. I have an example for you to clearly बुझिपारिबो. Suppose I am taking one of the most efficient catalyst in present scenario, that is your palladium. Palladium has 3 oxidation states. Or platinum you can take. Platinum has 3 oxidation states. That is PD0, PD2 plus, PD4 plus. Okay, if I am going from PD2 to PD4, I am giving you oxidation reaction. Then it will act as reducing agent. Okay, if I am going from PD2 to PD0, then I am doing reduction reaction. Then it will have oxidizing agent. If one species is acting both as a reducing and oxidizing agent, since it can undergo both oxidation reductions, then it can carry out many reactions. The property of a good catalyst is it can carry out many reactions with more effectiveness. Okay, clear? You are getting my point? So this is the advantage of multiple or variable oxidation state. If I am taking Na plus only have one oxidation state, +1. It can jump to Na only in one direction. It can gain electron, it will be reduced, undergoes reduction, so it will act as oxidizing agent only, if possible. Okay, but in these cases, due to multiple oxidation state, they can both carry out reactions very easily. Okay, just in the previous 2-3 slides, we have learned about complex formation ability. What does that mean? They can form complex easily. Okay, ସେମାନେ ଏତେ ସହଜରେ complex formation କରନ୍ତି complex formation जोगु reaction intermediate formation easy हो जाए intermediate किए जहाँ थ्रू reaction जाए product को reactant अच्छी product को जिबार अच्छी मझिरे आसी जाए intermediate এই intermediate formation टा अधिक नंबर ऑफ दरकार अधिक नंबर किंवा कम नंबर बॉन्ड फॉर्मेशन में पॉसिबिलिटी ଆଉ ସେଟା କାହା ଯୋଗୁ ହେଇପାରିବ ନା କମ୍ପ୍ଲେକ୍ସ ଫର୍ମେସନ ଯୋଗୁ ହେଇପାରିବ ହବ ସପୋଜ ପାଲାଡିୟମ ଦିଟା ବଣ୍ଡ କରୁଛି ତାକୁ ଦ୍ୱାରା 6ଟା ବଣ୍ଡ କରିବାର ଅଛି 6କୁ ଯିବା ପାଇଁ ସେ କେତେଟା ବଣ୍ଡ କରିବା ଦରକାର ପ୍ରଥମେ 4ଟା ବଣ୍ଡ କରିପାରିବ ତ ଏଇଟା ପସିବଲ କୋଉଥିରେ ଟ୍ରାନଜିସନ ମେଟାଲ୍ସ ରେ 4ଟା କଲା ପରେ ସେ 6ଟାକୁ ସପୋଜ ଗଲା ଠିକ ଅଛି 6ଟାକୁ ଗଲା କିଛି ଅସୁବିଧା ନାହିଁ ତ ଏଇ ଜିନିଷଟା ଟ୍ରାନଜିସନ ମେଟାଲ ରେ ପସିବଲ other possible no intermediate formation due to complex formation ability is more in case of transition metals is it clear तो ए बीटा रीजन तमरा आसे काहाथरे कैटालिटिक प्रॉपर्टीज रे आ तार किछटा एग्जांपल है ठीक अछि देखा एठो गोटे एग्जांपल अछि आयरन 3 कैटालाइजेस द रिएक्शन बिटवीन आयोडाइड एंड परसल्फेट आयोडाइड परसल्फेट दो चंदे कोन ये हेची देखा ऑक्सीडेशन है कि कोन हेची I2 ये रिडक्शन है कि एथिक जाइछो तो ए रिएक्शन को कैटालाइज किए करछि Fe3+ हमने जे कोठी कन्वर्ट हेची देखा Fe2+ कैटालिस्ट प्रॉपर्टी कोन कहे catalyst remains unchanged at the end of reaction start करथिला Fe3+ रे फाइनली पाइछो देखा Fe3+ सेकंड स्टेप करके Fe2+ का सेकंड स्टेप रे कहा को कैटालाइज करके H2O82- कोठी कन्वर्ट करके SO4 ओके चेक कर दवा एठी लॉस ऑफ इलेक्ट्रॉन हेची दिस इज ऑक्सीडेशन एठी गेन ऑफ इलेक्ट्रॉन हेची रिडक्शन कम भाई देखो केतरा माइनस चार्ज अछि दीटा एठी केतरा माइनस चार्ज अछि चारिटा त माने दीटा इलेक्ट्रॉन गेन हेछि खाली एठी कोन हो जायछि रिडक्शन हबा रिडक्शन पय रेस्पोंसिबल की अछि ए सेकंड स्टेप देखो रिडक्शन पय रेस्पोंसिबल अछि Fe2+ ऑक्सीडेशन पय की रेस्पोंसिबल अछि Fe3+ जब भी एफिटा केवल गोटे ऑक्सीडेशन स्टेट देखो तांदा ए रिएक्शन हेई पारे न थांता ये सब ओके आहुरी भी एग्जांपल अछि क्वेश्चन रे करिवा ठीक अछि आहुरी भी बहुत सारा तमरा बॉर्न हार्बर्स प्रोसेस अछि अमोनिया सिंथेसिस एटा देखि दउ मुंडन को पक देछि बॉर्न हार्बर्स प्रोसेस ए याको कहंती बॉर्न हार्बर्स प्रोसेस बॉर्न हार्बर्स प्रोसेस रे तमरा किए ये होछि आयरन थाई कैटालिस्ट हबा molybdenum थाई को कैटालिस्ट दिस इज ट्रांजिशन मेटल ओके कॉन्टैक्ट प्रोसेस स्लाइड का एक को कॉपी जाइस बाद डिलीट हो जाइस केन दो डाउन से बोलके तो पिला कॉन्सेप्ट रे सब तक वो लिखि देथि मुझे contact process रे concentrated H2SO4 prepare हुए previously platinum was used as a catalyst nowadays advancement जोगो V2O5 vanadium pentoxide is used as catalyst okay clear हमको गोटे टास्क देली ए भलिया जे कोन से स्टैंडर्ड बहिरे चारिटा एग्जांपल आउ लेखा होची 4 एग्जांपल्स ठीक अछि कैटालिटिक रा चारिटा एग्जांपल तो जेति देखिथिबो क्वेश्चन आंसर हम करू ठीक अछि ओके let us go to the next part this is your interstitial compound formation interstitial compound formation interstitial compound formation कौन कहला तो चेक करो this is called metal lattice गोटे जब solid metal piece गोटे नंबर that is the metal piece is called metal lattice ओके देखो ये टोटालटा होची गोटे मेटल लैटिस ओके ये जो व्हाइट बॉल गुडाक देखुछ एगुडाक दीज आर मेटल एटम्स ओके metal atoms जेतବେଳେ सज्जा ହେଇଛି we can verify here when these are arranged in a regular manner there is a gap you can see this gap this is the gap okay this gap is called your interstitial site not saying atom interstitial site you can see this is metal this is metal this is metal this is metal this gap is your interstitial site okay the interstitial site is very small in size साइज रे से कौन अच्छे very small अच्छे तो सीधे बड़ा atom के ही रही परिबे नहीं I am again saying the size is small so small that large atoms जदि मु कहि ए मेटल साइज रे गोटे atom ए भीतर रे आसीबो से रही परिबो नहीं large atoms cannot be fitted into interstitial site clear जबकि सभी बड़ा atom न रही परिए which are the atoms which can be accommodated को atoms को तमे रखि परिबो सबसे पहला small atoms like it carbon small atoms like carbon nitrogen hydrogen etc hydrogen carbon nitrogen boron etc. Interstitial compounds are formed when small atoms like hydrogen, carbon, nitrogen, boron are trapped inside the crystal lattice are called interstitial compounds. Okay. Usually these are not stoichiometric compounds. माने धर्मो कहिबी एठी टाइटानियम नेली 4 कार्बन नेबी 1:1 तमाने चारियाडा रेशियोटा 4:1 रहिबो एमिति परफेक्ट रेशियो रे केबे भी से माने न थांती हियर यू कैन चेक vanadium is 1 but hydrogen is 0.56 this is not a whole number ratio okay this is not fixed it can be changed what second time the interstitial compounds are good substitution say interstitial compounds are stoichiometric compounds and non-stoichiometric compounds these are non-stoichiometric compounds are neither typically ionic nor covalent it can be considered trap hiki rahi jaitanti semane completely ionic na complete covalent bond formation karanti nahi se bitare completely trap hiki achanti trap hiki rahiba jogo किछि प्रॉपर्टी एनहांस हो जाए बट कंप्लीट बॉन्डिंग हुए नहीं जेहेतु नॉन स्टोइकोमेट्रिक कंपाउंड कंप्लीट बॉन्ड ही परिबो नहीं बॉन्ड पाई परफेक्ट रेशियो दरकार ओके तो दिस आर कॉल्ड ठीक अछि या जोगो एमानकर कैरेक्टरिस्टिक्स कोन हो जाए जदि मु प्योर मेटल नै थिली इंटरस्टिशियल कंपाउंड ही गला करे कोन हो जाए ठीक अछि को प्रॉपर्टी तांकर बढ़ी जाए ठीक है से कहला जब तुम प्योर मेटल लेचा ताकू इंटरस्टिशियल कंपाउंड कर देचा आफ्टर फॉर्मेशन ऑफ इंटरस्टिशियल कंपाउंड मेल्टिंग पॉइंट इंक्रीजेस हाई मेल्टिंग पॉइंट हो जिवो तमने से आगे जति की स्टेबिलिटी थिला थर्मल स्टेबिलिटी the thermal stability increases this is nothing but your thermal stability increases ओके बोराइड्स जब बोरॉन रहे है ना बोरॉन रही गले मेटल भितरे इट अप्रोचेस डायमंड हार्डनेस माने आई मीन से मोस्ट हार्डेस्ट कंपाउंड इन वर्ल्ड के है डायमंड है तो इंटरस्टिशियल कंपाउंड मिसी गला परे दे आर बिकमिंग सो हार्ड दैट इट इज इक्विवेलेंट टू डायमंड डायमंड सहित से समान हो जाती। ओके, तापर रहा रिटर्न मेटालिक कंडक्टिविटी। देख आम जो कहूचे धर कार्बन ड्राफ्ट होची टाइटानियम रे कार्बन इज योर नॉन मेटल, यू आर थिंकिंग दैट इट्स मेटालिक कंडक्टिविटी विल बी रिड्यूस्ड कंबाइना एटा मेटल एटा नॉन मेटल, मेटल जो कंडक्टेंस थिला कंडक्टिविटी थिला ना नॉन मेटल आसला कमी जीव ना सेमती होना एमाने डायरेक्ट बॉन्ड फॉर्मेशन करि नहंती एमाने ट्रैक होई जायछंती सो they retain their metallic conductivity, generally metallic conductivity change हुए नहीं। okay, and they are chemically inert। आगରୁ टाइटानियम खाली रखिथिबो से रिएक्टिव थिबो ଯଦି ସେ टाइटानियम सी हेगला से रिएक्टिविटी तार कमी ଯିବ से सहजरे रिएक्शन करिवो नहीं, केमिकली इनर्ट हो जाନ୍ତି। ठीक है, okay, characteristics। okay, last part is your alloy formation, alloy definition। last year it is asked in council, it is asked in entrances also। an alloy is a blend of metals prepared by mixing the components when the metal मिसिकी यूनिफॉर्म सॉल्यूशन कले ताकू कहाजे सेतबे लेखा डेफिनेशन लिखा है alloys may be homogeneous solid, this word is important, homogeneous solid solution in which atoms of one metal is distributed randomly among the atoms of other metals, गोटे मेटल रे अदर मेटल को मिसेइबो तो ताकू कहाजे alloy formation। केमिति होइछि देखो गोटे मेटल नेछि एटा एथरे कोनोसी अदर मेटल नै, these are metal atoms, this is another metal having these atoms, when we are mixing see both are present in this framework। okay, so this is called your alloy। ठीक है, गोटे मेटल सॉलिड मेटल नेला ताको मेल्ट कला याको मेल्ट कला जेते को मिसेला पर यूनिफॉर्म सॉल्यूशन कर देला तापर ताको कूल कर दो, यूनिफॉर्मिटी मस्ट बी देयर, होमोजेनियस मिक्सचर हवा जाता है, होमोजेनियस मिक्सचर। ओके, सो alloy रे preparation properties of alloy कौन कहू, they are very hard, सेतमे आजिकल देखियो alloy wheels यूज होछि बाइक ये सब। ठीक है, एटा गोटे इंपोर्टेंट क्वेश्चन नथा को मेटल मिसी परिबे तर गोटे मेटल रा साइज एते बड़ अछि गोटे मेटल एति छोट अछि, कैन दे फॉर्म alloy? no, this is the condition, transition metal form alloy due to similar radii along with other characteristics। केते रेडाई का सिमिलर हबे दरकार 15% ऑफ ईच अदर, माने गोटे धर ये अछि एति की साइज अछि यार 15% प्लस माइनस कर दबो, 15% ताठू बड़ ही करे किंबा 15% ताठू छोट ही करे, ता माने पाखापाखी कंपेरेबल साइज रा हबा दरकार। ओके, केते कम परसेंट कहली 15%, रिमेंबर दिस वन 15% plus minus radius रे they can form alloy। ठीक है, often they have very high melting point, alloy करे तंगर melting point बढ़ते जेंतु दी मेटल रहिले तंकर better conductivity, better electronic conditions are shown। ओके, इतनीटा हला तंगर चेंज होइछि कोन प्रॉपर्टीज। ठीक है, alloy रे तो ना जानिछ ब्रास ब्रोंज एगुडा। ठीक है, ferrous alloy, steel joints, stainless steel joints, iron containing alloy। ferrous alloy means they must have iron। okay, ठीक है, एक कंपोनेंट देखि देखाओ के अछंती। ठीक है, stainless steel रे ए कंपाउंड अछंती। आ गोटे एक्स्ट्रा जिंस मन रखिथिबो, stainless steel has carbon but steel has no carbon। okay, stainless steel has carbon, remember stainless steel has carbon but steel has no carbon। okay, brass is your main metal is copper, another is zinc, bronze is copper, 15, like this. These are the examples. Okay. I think we have studied all properties of D block elements. Now we will take 5 to 10 minutes break. Then we will start the second session. Okay.